June 1956, Portsmouth Naval Shipyard, Kittery, Maine. The commanding officer of USS Sailfish, Lieutenant Commander Stanley McCord, stood on the pier watching welders attach the final sections of a radar array to his submarine's sail that made the vessel look like it had grown a tumor. The BPS-2 search radar antenna rose 23 feet above the normal sail height, enclosed in a fiberglass housing that added another 16 tons to a submarine designed for hydrodynamic efficiency, and the entire structure vibrated visibly in the wind coming off the Piscataqua River, making sounds like sheet metal flexing under stress that could be heard from 50 yards away. The temperature held at 42 degrees under overcast skies that threatened rain, and condensation dripped from the massive radome housing onto the submarine's deck, where puddles formed around drainage holes that had never been designed to handle runoff from equipment 30 feet overhead. Sailfish was a Sailfish-class radar Picket submarine, SSR 572, built for a mission that seemed straightforward in concept and nightmarish in execution. Surface in the North Atlantic or Bering Sea, extend the radar mast, and detect Soviet bomber formations approaching American airspace hours before land-based radar could see them, then dive before enemy aircraft could locate and destroy the sitting duck that radar emissions made her. The mission requirements violated every principle of submarine warfare that had evolved through 2 world wars and the emerging Cold War. Submarines survived through stealth, concealment, the ability to disappear beneath the ocean surface and become invisible to enemy detection systems. But radar Picket operations required Sailfish to surface, making her visible to aircraft and surface vessels, and then broadcast her exact position by radiating electromagnetic energy that any Soviet aircraft equipped with radar warning receivers could detect from hundreds of miles away. The sail-mounted BPS-2 radar had a range of approximately 150 nautical miles against aircraft-sized targets, which meant Sailfish would detect incoming bombers long before they reached American territory. But the radar's powerful transmissions would also advertise the submarine's location to every enemy platform within detection range. Surface. Radiate. Wait. Hope the bombers arrived before the submarines, surface vessels, or aircraft that would inevitably converge on the radar source. The Navy had commissioned Sailfish in April 1956 specifically for this mission, along with her sister ship USS Salmon, SSR 573, based on strategic assumptions that seemed reasonable when planning began in the early 1950s, but were already showing cracks by the time the welders finished installing the radar equipment. The Soviet Union possessed large bomber fleets, primarily Tupolev Tu-95 Bears and Myasishchev M4 Bisons, capable of reaching American cities by flying over the Arctic or Atlantic approaches. Ground-based radar stations provided coverage, but gaps existed in the early warning network, particularly over ocean areas where no land existed for radar installations. Submarines equipped with air search radar could patrol those gaps, extending the radar fence hundreds of miles from shore, providing crucial early warning time for air defense interceptors to scramble and engage the bombers before they reached population centers. But the mission had problems that became apparent the moment operational planning began in detail. A submarine on the surface in the North Atlantic during winter faced seas that could reach 30 feet or higher, waves that would slam against the radar housing with force sufficient to tear the entire structure from the sail. Salt spray would coat every exposed surface, creating corrosion problems that required constant maintenance and threatened radar performance. Ice would form on the radome during winter operations, adding weight and degrading radar returns. The crew would need to remain surfaced for hours, sometimes days, maintaining radar watch while vulnerable to detection and attack, unable to dive quickly if threatened, because the radar mast required several minutes to retract into the housing before the submarine could submerge without damaging the equipment. The operational concept assumed Soviet bombers would approach in formations large enough for radar detection at maximum range, giving Sailfish time to report the contact, receive acknowledgement from shore stations, retract the radar, and dive to safety before enemy aircraft could locate and attack the submarine, broadcasting electromagnetic signals like a lighthouse. But what if the Soviets detected Sailfish first? What if they sent submarines to hunt the radar pickets, or dispatched aircraft equipped with anti-submarine weapons to patrol the areas where radar picket submarines were expected to operate? What if shore stations failed to receive the warning transmission, forcing Sailfish to remain surfaced and continue broadcasting until acknowledgement arrived? Every scenario planners examined revealed vulnerabilities that made radar picket operations appear less like early warning missions and more like suicide assignments, where submarines volunteered to become targets. The engineering challenges were substantial enough that Portsmouth Naval Shipyard required 8 months of modification work to install the radar system and associated equipment on Sailfish's existing hull. The BPS-2 radar itself weighed over 3 tons, mounted on a mast that extended through a pressure-tight trunk in the sail. Power cables ran from the reactor compartment through waterproof conduits to the radar equipment. A dedicated radar operating station was installed in the control room, with displays and communications equipment for reporting contacts to shore facilities. Ballast tanks were modified to compensate for the added topside weight that raised Sailfish's center of gravity and made her less stable on the surface. Strengthening members were welded into the sail structure to support loads the original design never anticipated. Every modification added weight, complexity, and maintenance requirements to a submarine that would spend most of its operational life in the same rough ocean conditions that destroyed surface ships and challenged even the largest vessels. If you are enjoying this investigation into history's hidden conflicts, please verify your subscription to the channel Cold War Chronicles. We declassify the past to understand the present. The first operational patrol deployment orders arrived in October 1956, assigning Sailfish to a patrol area in the North Atlantic, approximately 400 miles east of Newfoundland, where Soviet bomber routes from Arctic bases would cross if they were approaching the northeastern United States. The commanding officer reviewed the orders in his stateroom, noting that the patrol duration was listed as 30 days, during which Sailfish was expected to maintain radar watch for 8 hours per day, surfaced and radiating in ocean areas where Atlantic weather patterns generated storms that regularly exceeded Force 8 on the Beaufort scale. 30 days, 8 hours surfaced daily, in the North Atlantic, in winter. The orders made no mention of what Sailfish should do if Soviet submarines or aircraft detected the radar emissions and converged on her position, though standard doctrine presumably applied: dive and evade, break contact, resume patrol when safe. Standard doctrine for circumstances that were anything but standard. But before Sailfish could deploy on her first operational patrol, reports began arriving at the Office of Naval Intelligence in Washington that raised questions about whether the entire radar picket submarine concept was based on assumptions that were already obsolete. The Air Force was developing airborne early warning aircraft, eventually designated EC-121 Warning Star, that could fly barrier patrols over ocean areas and provide radar coverage without the vulnerabilities that submarines faced when surfaced. Ground-based radar technology was improving, with systems like the Distant Early Warning Line extending coverage further north and closing gaps in the early warning network. Satellite reconnaissance programs were beginning development, though operational satellites remained years away. They promised detection capabilities that would eventually make surface-based radar platforms unnecessary. Item 1. In September 1956, the Air Force conducted experimental EC-121 barrier patrols over the North Atlantic and demonstrated that aircraft could maintain radar coverage for extended periods while remaining mobile enough to avoid enemy interception, something submarines could never achieve while surfaced and stationary. Item 2. In November 1956, analysis of Soviet bomber flight profiles suggested that bears and bisons would approach at altitudes and speeds that gave them time to detect and evade radar picket submarines before the submarines could dive to safety, potentially turning the hunters into targets. Item 3. In December 1956, Navy wargames simulating radar picket operations resulted in simulated losses of submarines in 70% of scenarios where enemy forces detected and engaged the surfaced vessels. Casualty rates that were unacceptable for a mission that was supposed to provide early warning, not serve as sacrificial decoys. In a classified briefing room at the Pentagon, officers from the Office of Naval Intelligence presented findings to senior Navy leadership that questioned whether radar picket submarines should deploy operationally at all. The briefing charts showed comparative analysis of detection ranges versus vulnerability windows, how long Sailfish would need to remain surfaced to detect bombers versus how quickly enemy forces could converge on the radar emissions and engage the submarine before she could dive. The numbers were not encouraging. A bomber detected at 150 miles would give Sailfish approximately 40 minutes of warning time before the aircraft reached American airspace, assuming the bomber maintained constant course and speed. But retracting the radar mast and diving required 10 minutes minimum, and Soviet aircraft equipped with radar homing missiles could potentially detect and engage Sailfish from ranges exceeding 50 miles, cutting the available warning time to dangerously narrow margins. The psychological assessment of crews assigned to radar picket submarines revealed concerns that operational commanders had anticipated but hoped to mitigate through training and mission rotation. Submarine duty already imposed psychological stress from confinement, isolation, and the constant awareness that the ocean depth surrounding the pressure hull could crush the vessel instantly if systems failed. But radar picket operations added a layer of vulnerability that fundamentally changed the psychological calculus. Submariners accepted danger as part of their profession, but danger that came with the ability to evade and hide, to use depth and silence as defensive weapons. Radar picket missions stripped away those defenses, required crews to surface deliberately in hostile waters and broadcast their positions, to volunteer for detection in exchange for providing early warning that might save cities they would never see again if enemy forces responded before the submarine could dive to safety. The strategic justification for radar picket submarines had seemed compelling when the concept originated in 1952, born from analyses of Soviet bomber capabilities and gaps in American air defense networks that planners feared would allow nuclear-armed aircraft to approach population centers undetected until they were minutes from target. The continental United States possessed extensive ground-based radar coverage inland with installations positioned across the northern tier of states and along both coasts, but ocean approaches presented coverage gaps that extended hundreds of miles offshore where no terrain existed for radar sites and where early warning time could mean the difference between successful interceptor engagements and bombers reaching their targets unopposed. Aircraft carrier-based radar picket planes provided mobile coverage, but carriers could not patrol every potential approach route simultaneously, and their operational areas were constrained by weather, logistics, and the vulnerability of surface vessels to submarine attack. Submarines offered advantages that seemed to solve multiple problems. They could patrol indefinitely powered by nuclear reactors, could remain on station in weather that grounded aircraft, and could theoretically dive to safety if threatened, making them more survivable than surface radar picket vessels that had proven devastatingly vulnerable during World War II, when Japanese kamikaze attacks specifically targeted radar picket destroyers positioned around Okinawa. But those theoretical advantages depended on operational realities that proved far more complex and problematic than early planning documents acknowledged. The Navy had built Sailfish and Salmon based on projections of threat timelines and defensive requirements that assumed Soviet bomber technology would remain relatively static, while American detection and interception capabilities improved incrementally, giving radar picket submarines an operational window of perhaps 5 to 7 years, during which they would provide crucial capabilities that no other platform could deliver. Instead, technology evolved in directions that made radar picket submarines simultaneously more necessary and more obsolete within months of their commissioning. Soviet bombers were flying higher and faster than intelligence estimates had projected, reducing the time available for detection and interception. American air defense systems were improving rapidly with the deployment of supersonic interceptors, like the F-106 Delta Dart, and surface-to-air missiles, like the Nike Ajax. Systems that required longer warning times to achieve optimal positioning, but could engage targets at ranges and altitudes that earlier systems could not reach. The radar Picket submarines were caught between escalating requirements and diminishing relevance as alternative systems demonstrated equal or superior capabilities without the vulnerabilities inherent in surfaced submarine operations. USS Sailfish completed initial sea trials in early 1957, testing the radar systems and operational procedures that would govern actual patrol deployments if the Navy decided to commit radar Picket submarines to active service rather than relegating them to experimental status or alternative missions. The trials revealed problems that engineering analysis had predicted but could not fully quantify until real-world operations tested equipment under actual ocean conditions. The radar mast vibrated excessively when extended in even moderate seas, creating metal fatigue concerns in the mounting structure and degrading radar performance as the antenna oscillated through arcs that blurred returns and created false contacts. Salt spray penetrated the radome housing, despite seals and gaskets designed to keep moisture away from sensitive electronics, causing corrosion that required constant maintenance and threatened system reliability during extended operations. The submarine's handling characteristics changed dramatically when the radar mast was extended, with the added windage acting like a sail that made maintaining heading difficult in crosswinds and created dangerous rolling moments when waves struck the sail from beam angles. Diving with the mast extended was impossible without risking structural damage, and the retraction procedure required precise coordination between radar operators, diving officers, and ballast control teams. A complex choreography that could take 12 minutes in ideal conditions and much longer if equipment malfunctioned or sea conditions interfered with normal procedures. The first operational deployment orders were issued and then rescinded 3 times during 1957, as Navy leadership debated whether radar Picket submarines should conduct actual barrier patrols or remain in training status, while strategic reviews determined their future role in air defense networks that were evolving faster than procurement timelines could accommodate. Each postponement added to crew frustration and raised questions about whether the submarines had any viable mission at all or represented expensive technological dead ends that institutional momentum kept alive, despite mounting evidence that their operational concept was fundamentally flawed. Submariners assigned to Sailfish and Salmon found themselves in professional limbo, trained for missions that might never occur, operating vessels that seemed designed for scenarios that were disappearing even as the submarines completed construction. The radar equipment worked as designed. The reactors provided unlimited endurance. The hulls were sound, and the crews were competent. But none of those factors addressed the fundamental question. What were radar Picket submarines supposed to accomplish that other systems could not do better, safer, and more cost-effectively? The Air Force's EC-121 Warning Star aircraft were conducting operational barrier patrols by late 1957, flying continuous coverage missions over the North Atlantic and North Pacific, using rotating crews and aerial refueling to maintain radar watch over ocean areas where submarines would have operated if deployed. The aircraft carried more powerful radars with longer detection ranges than submarine-mounted systems, could reposition rapidly in response to changing threat patterns, and remained invulnerable to submarine attack while airborne. The operational costs were substantial. Each barrier patrol mission required multiple aircraft, tanker support, and extensive logistics. But the costs were comparable to maintaining nuclear submarines on extended patrols, and the aircraft could be recalled instantly if no longer needed, something submarines at sea could not do without breaking patrol and returning to port. The Warning Star operations demonstrated that airborne platforms could provide the early warning coverage that radar Picket submarines had been designed to deliver and could do so without requiring crews to surface in hostile waters and broadcast their positions to enemy forces actively searching for exactly those radar emissions. If you are enjoying this investigation into history's hidden conflicts, please verify your subscription to the channel Cold War Chronicles. We declassify the past to understand the present. Satellite technology development added another layer of obsolescence to radar Picket submarine concepts, though operational satellites remained years from deployment when Sailfish was commissioned. Intelligence agencies were funding research into reconnaissance satellites that could detect bomber formations from orbit, providing global coverage without requiring platforms positioned in threatened areas where enemy forces could engage them. The satellites would need years of development before becoming operational, but their existence on development timelines indicated that detection technologies were moving towards space-based systems that would eventually make surface and airborne platforms redundant for strategic early warning missions. The radar Picket submarines were designed for a detection gap that was already closing through alternative means, and the gap would disappear completely within a decade as satellites, improved ground radar, and airborne warning systems created overlapping coverage that eliminated the blind spots submarines were supposed to fill. The Navy's Strategic Systems Project Office conducted a comprehensive review of radar Picket submarine utility in 1958, examining operational scenarios, cost-effectiveness comparisons with alternative systems, and projections of future air defense requirements that would determine whether Sailfish and Salmon should continue in their designed roles or be converted to different missions that might leverage their capabilities more effectively. The review team analyzed Soviet bomber development programs, American air defense modernization plans, emerging satellite technologies, and operational experience from EC-121 barrier patrols to determine whether radar Picket submarines offered unique capabilities that justified their continued operation in roles that were proving increasingly questionable. The classified report submitted to the Chief of Naval Operations in September 1958 concluded that radar Picket submarines provided marginal capabilities that did not justify the operational risks, maintenance costs, and crew assignments required to keep them in their design configuration, and recommended conversion to attack submarine roles that would use their nuclear propulsion and hull designs for missions where submarines offered clear advantages over alternative platforms. The conversion recommendation acknowledged that Sailfish and Salmon represented substantial investments that should not be wasted, but argued that their value lay in their nuclear propulsion systems and hull designs rather than their radar Picket equipment, which had proven problematic in operation and redundant in coverage capabilities. Removing the radar arrays and associated equipment would improve the submarine's hydrodynamic performance, reduce maintenance requirements, eliminate the operational vulnerabilities inherent in radar Picket missions, and free the vessels for attack submarine operations where the Navy faced capability gaps and expanding operational requirements. The Soviet submarine fleet was growing rapidly, with nuclear-powered vessels beginning to appear in numbers that challenged American anti-submarine warfare capabilities, and attack submarines were needed to track Soviet boats and maintain the acoustic intelligence necessary for developing effective countermeasures. Sailfish and Salmon could serve those missions more effectively than they could serve radar Picket roles that were already being performed better by aircraft and would soon be performed better by satellites. The decision to convert USS Sailfish from radar Picket configuration to attack submarine was approved in 1961, acknowledging that the vessel had spent 5 years in service without ever conducting an operational radar Picket patrol, her designed mission abandoned before she ever deployed on the mission she was built to perform. The massive BPS-2 radar array was removed from the sail, the fiberglass housing dismantled, the mounting structure cut away, and the sail restored to conventional streamlined configuration that reduced drag and improved submerged handling. The radar operating station in the control room was stripped out and replaced with standard sonar and fire control equipment. The ballast modifications were partially reversed to restore the submarine's designed stability characteristics. Sailfish emerged from the conversion as a conventional attack submarine. Her brief career as a radar picket boat, ending without a single operational patrol in the role that had justified her construction. A vessel designed for missions that disappeared before they began, made obsolete by technological developments that rendered her specialized capabilities redundant before they were ever employed in actual operations against the threats they were designed to counter. The failure of the radar picket submarine concept represented more than a tactical miscalculation or procurement mistake. It exemplified the challenges of developing military systems for threats and scenarios that evolved faster than development and construction timelines could accommodate. Sailfish had been designed in the early 1950s based on threat assessments and technological capabilities that seemed reasonable at the time, but were overtaken by developments in Soviet bomber performance, American detection technologies, and alternative platform capabilities before the submarine could deploy operationally. The Navy had committed resources, engineering effort, and crew assignments to vessels whose missions evaporated during the construction period, leaving expensive platforms searching for roles that could justify their existence. The conversion to attack submarine configuration salvaged some utility from the investment, but could not change the fundamental reality that radar picket submarines had been built to fill gaps that close through other means, designed for scenarios that never materialized, optimized for threats that evolved beyond the operational concepts that had seemed viable when keels were laid and construction contracts were signed. The operational history of USS Sailfish after her conversion to attack submarine configuration demonstrated that the vessel's basic design remained sound even if her original mission had proven unworkable, and the nuclear propulsion system and hull characteristics that had been developed for radar picket operations translated effectively to conventional submarine warfare roles, where endurance and submerged performance mattered more than specialized detection equipment that had never functioned as intended in actual service. Sailfish deployed on standard attack submarine patrols throughout the 1960s and 1970s, conducting surveillance operations, tracking Soviet submarines, participating in NATO exercises, and performing the routine missions that constituted the bulk of Cold War submarine operations during decades when nuclear-armed vessels from both superpowers prowled the oceans in a silent contest for strategic advantage and tactical superiority. The conversion had removed the distinctive radar housing that made Sailfish instantly recognizable and replaced it with conventional sail configuration that made her indistinguishable from other attack submarines of similar vintage, erasing the physical evidence of her failed original mission while preserving the platform for uses that proved more enduring than the radar picket concept that had justified her construction. USS Salmon underwent identical conversion in 1961, following her sister ship into attack submarine configuration after similarly spending years in service without conducting operational radar picket patrols. The two submarines representing the entirety of a submarine class that had been conceived, designed, constructed, and abandoned within a decade as technological developments and strategic reassessments rendered their specialized capabilities obsolete before they could be employed. The Navy had planned additional radar picket submarines beyond Sailfish and Salmon, with preliminary designs developed for improved vessels, incorporating lessons from the first two boats and featuring enhanced radar systems, better seakeeping characteristics, and improved defensive capabilities that might have addressed some of the vulnerabilities that made radar picket operations so problematic. But those plans were cancelled in 1958 when the Strategic Review determined that existing radar picket submarines provided insufficient value to justify additional construction, and that resources would be better allocated to attack submarines, ballistic missile submarines, and other platforms whose missions remained viable in the evolving strategic environment, where satellites and aircraft were assuming early warning responsibilities that submarines could not perform effectively. The broader implications of the radar picket submarine failure extended beyond the specific vessels and their aborted missions to illuminate fundamental challenges in military procurement and capability development during periods of rapid technological change, when threat assessments and defensive requirements evolved faster than construction timelines could deliver systems designed to address them. The Navy had identified a legitimate gap in air defense coverage, developed a reasonable concept for filling that gap using submarine platforms that offered theoretical advantages, committed resources to building specialized vessels optimized for radar picket missions, and watched the entire rationale disappear as alternative technologies matured and Soviet threats evolved in directions that made the original concept less relevant. The time lag between concept development and operational deployment had proven fatal to the radar picket submarine program, with roughly 8 years elapsing between initial planning and completion of Sailfish. 8 years during which air defense technologies, bomber capabilities, and detection systems advanced so dramatically that the mission Sailfish was designed to perform had been superseded by other means before she ever deployed to perform it. The experience influenced subsequent Navy planning and procurement decisions, reinforcing lessons about the dangers of developing highly specialized platforms for narrow mission sets that might disappear before construction completed, and encouraging emphasis on flexible multi-mission designs that could adapt to changing requirements rather than vessels optimized for specific scenarios that might prove temporary or irrelevant. Attack submarines offered flexibility that radar picket submarines lacked, capable of performing surveillance, anti-submarine warfare, intelligence gathering, and eventually land attack missions using a common platform that could be reassigned between roles as priorities shifted. Ballistic missile submarines served the enduring mission of nuclear deterrence that remained constant across decades, despite changes in delivery systems and targeting doctrines. But radar picket submarines served only one mission, and when that mission evaporated, the vessels had no alternative roles except the attack submarine conversion that erased their specialized characteristics and turned them into conventional platforms that could have been built more cheaply and effectively without the radar equipment that had never functioned operationally. The technological trajectory that made radar picket submarines obsolete continued accelerating through the 1960s and 1970s as satellites, over-the-horizon radar, and improved early warning systems created detection networks that covered potential bomber approach routes with redundancy and reliability that surface or subsurface platforms could never match. The Defense Support Program satellites launched beginning in 1970 provided infrared detection of ballistic missile launches and bomber formations from geosynchronous orbit, covering the entire Soviet Union and potential approach routes with continuous surveillance that could not be jammed, evaded, or attacked except through anti-satellite weapons that remained limited throughout the Cold War. Ground-based over-the-horizon radar systems used ionospheric reflection to detect aircraft at ranges exceeding 2,000 miles, providing early warning times measured in hours rather than minutes, and eliminating the coverage gaps that had justified radar picket submarines in the 1950s. The Airborne Warning and Control System aircraft that entered service in 1977 combined powerful radar with command and control capabilities that made them mobile early warning platforms capable of detecting, tracking, and coordinating responses to air threats across wide areas while remaining defensible and survivable in ways that surfaced submarines could never achieve. USS Sailfish continued operating as an attack submarine until decommissioning in September 1978, completing 22 years of service that included only the final 17 years in her converted configuration after the radar picket mission proved unworkable. The decommissioning ceremony at Mare Island Naval Shipyard attracted minimal attention despite Sailfish's unusual history, the submarine having faded into routine service after her spectacular failure to perform the mission that had justified her construction, remembered primarily as a cautionary example of military procurement gone awry, rather than as a successful platform that had served with distinction. The crew that attended the ceremony had operated Sailfish as a conventional attack submarine and knew little of her radar Picket origins, except through historical summaries that described the massive radar housing and aborted mission profile that had defined her early years. The vessel they knew was unremarkable, a competent if aging attack submarine that performed adequately without distinguishing herself, her service record reflecting steady routine operations rather than dramatic achievements or notable failures. The scrapping followed. Scrapping. Immediately after decommissioning in 1978, unusual timing that suggested the Navy saw no value in preserving Sailfish, even in reserve status, where other submarines of similar vintage were maintained as potential mobilization assets or training platforms. The decision to scrap immediately, rather than preserve, reflected both the submarine's age and the reality that her design offered nothing worth retaining for future use. The radar Picket modifications having been removed decades earlier, and the basic hull design representing 1950s technology that had been superseded by newer submarines with superior capabilities. Sailfish was towed to a commercial scrapping facility where cutting torches reduced her to salvageable metal over several months. The reactor compartment removed for separate disposal following established nuclear submarine recycling procedures. The pressure hull sectioned and sold for scrap. The components and systems stripped and recycled, every physical trace of the vessel disappearing, except for photographs and documents that recorded her existence and the failed mission concept that had defined her purpose. USS Salmon met the same fate, decommissioned in 1977 and scrapped in 1978, the two radar Picket submarines disappearing within a year of each other, after careers that had begun with specialized missions that never occurred and ended with routine service that provided no lasting legacy beyond the lessons their failure taught about military procurement and technological change. The Navy retained no radar Picket submarines after Salmon's decommissioning, the concept having been thoroughly abandoned decades earlier, when conversions removed the last physical evidence of the program from active vessels. No museum preserved either submarine, their histories deemed insufficiently significant to warrant preservation when space and resources were limited, and other vessels offered more compelling narratives or represented more successful programs worth commemorating for future generations. The lessons from the radar Picket submarine program resonated through subsequent Navy procurement decisions and strategic planning processes, though whether those lessons were adequately learned remained debatable, as later programs repeated similar patterns of developing specialized platforms for missions that disappeared before deployment. The fundamental challenge remained unchanged. Military planning required years or decades to move from concept to operational capability, but threats and technologies evolved continuously, creating persistent risk that systems designed for current threats would prove irrelevant against future challenges that emerged during development timelines. Flexibility and adaptability offered partial solutions, allowing platforms to serve multiple missions or adapt to changing requirements. But some missions required specialized equipment that could not easily be repurposed when circumstances changed. Radar Picket submarines represented an extreme case where specialization proved fatal to the program. But similar dynamics affected other procurement efforts where narrow mission focus created vulnerability to technological or strategic changes that undermined the original justification. The radar Picket submarine concept had emerged from legitimate strategic concerns about air defense coverage gaps and Soviet bomber threats that seemed compelling in the early 1950s, when atomic weapons and long-range aircraft created new vulnerabilities that existing defense systems could not adequately address. The Navy's response, building submarines with massive radar arrays to patrol ocean areas where other platforms could not maintain continuous coverage, represented creative thinking about how to leverage submarine endurance and mobility for missions beyond traditional warfare roles. But creative thinking could not overcome the fundamental problems inherent in requiring submarines to surface in hostile waters and broadcast their positions, exposing them to risks that contradicted every principle of submarine operations while providing capabilities that alternative systems delivered more effectively with fewer vulnerabilities. The concept failed not because it was poorly executed, but because it was inherently flawed, asking submarines to perform missions that violated their core advantages while accepting vulnerabilities that made the missions untenable in actual operations. USS Sailfish's legacy existed primarily in negative lessons about what not to build and how not to develop military systems for rapidly evolving strategic environments where technological change could render specialized platforms obsolete before they deployed. The submarine herself had been competently designed and built. Her reactor functioned reliably, her hull proved sound, her systems performed adequately when converted to conventional attack submarine configuration. But none of those positive attributes could salvage a program whose fundamental premise had been overtaken by events before the first operational patrol could occur. Sailfish represented expensive capability that was never used for its intended purpose. A vessel designed to detect bombers that ended her career, hunting submarines after the radar equipment was removed and the original mission abandoned. The Navy had invested substantial resources in developing, building, and operating radar Picket submarines that never performed radar Picket missions, creating platforms that served primarily as examples of procurement failure and cautionary tales about the dangers of specialized designs in periods of rapid technological change. The air defense mission that radar Picket submarines were supposed to perform continued evolving through the remainder of the Cold War, with satellites, advanced radar systems, and integrated detection networks, creating layered coverage that eliminated the gaps Sailfish had been built to fill. Soviet bombers remained, threats that required continuous monitoring and defensive preparations, but the monitoring came from space-based sensors and ground-based systems, rather than submarines surfacing in ocean patrol areas to extend radar coverage over water approaches. The strategic bomber threat itself declined relative to ballistic missiles as delivery systems evolved, and both superpowers invested heavily in ICBMs and submarine-launched ballistic missiles that could strike with minimal warning from positions that made defense nearly impossible. The air defense problem that had seemed so urgent in the 1950s persisted through the Cold War, but was addressed through means that did not require submarines to surface and radiate. The technological developments that made radar Picket submarines obsolete continuing to advance until the entire strategic context had shifted beyond the scenarios that had justified their construction. The submarine designed to detect bombers had failed before she ever deployed, her mission disappearing during the years between concept and completion, her specialized equipment removed after proving operationally unworkable, her career salvaged through conversion to conventional roles that required erasing every trace of the purpose she had been built to serve. USS Sailfish had represented the Navy's attempt to solve a real problem with an innovative platform, but innovation alone could not overcome the fundamental incompatibility between submarine operations and radar Picket missions, and could not prevent alternative technologies from providing better solutions before Sailfish could prove her worth. The radar Picket submarine program stood as testament to the challenges of military procurement in technological transition periods, a cautionary example of how systems designed for current threats could become irrelevant before deployment, when development timelines stretched across years and strategic environments evolved continuously. Sailfish had been obsolete at commissioning, her mission gone before her service began, a submarine built for a gap that closed before she could fill it.